All right, let's try this again. And by again, I mean because you see something's already written, but my phone was blowing up because people needed help, which is great. So I decided to just start the whole thing over. By the way, I posted or sent, I'll probably post it on eCampus too, but I sent out a message in Messenger. Guys, if you need extra help and these things aren't, giving you everything you need, it's fine. Um, you can shoot me a text or whatever. I send a link for WebEx meetings. You can do it on your computer. There's an app for it. I know on the iPhone for sure. It's a link to my room or my meeting room or whatever. And as long as I'm available and you need help, you can just use that code and I'll just open the room and we can do it that way. And I can walk through things with you. So anyway, so back to this. We're going to continue graphing sine and cosine. I've written down the general equations for them. And next year, for those of you that go into pre-calc, you'll be doing the same thing, except they put the b inside here. Sometimes it will be for us, but you'll have to divide it out and divide it by both of them, kind of factor it out. So I like to put it out there. So this kind of resembles the A, H, and K thing, except we added in an extra. We've got an A, we got a B, C, and D. So A is just like it always was. It's a reflection. If it's a negative A, it's a reflection. The absolute value of A is the amplitude. That's how high it is, how high each wave is or crest is. It's from, if you remember from the last set of notes. Okay. Now, if A is greater than 0, in other words, positive. Okay. If A is greater than 0 and D is 0, that's important. Because D is our midline. D is like our x-axis. That's the shift up and down. But if those are both, if this is greater than 0 and D is 0, in other words, there's nothing there, then A is going to be my max. It's going to be my max value. And the opposite of that, or negative A, will be my min value. Okay? Make sure this is in focus here. Looks pretty good to me. All right. Who's interested in me right now? Okay. No. All right. So now we go to B. Now B is very important. Remember we talked about in the last lesson about the period, how long it takes it to repeat. And for cosine and sine, it was 2 pi or 360 degrees. Well, these values can have an effect on that. Matter of fact, B has an effect on that. So our period length, in other words, how long it's going to take the cycle to go through, all right, is always going to come from either 360 degrees divided by B or 2 pi, because that's the same thing, divided by B. All right. Now, when it's 2 pi or 360, we count by 90 degrees, because 90, 90, 90, 90 gives us the complete circle. That's 4 steps, but 5 stairs, if you will. If you remember when we talked about that in, what was that? In series and sequences, same thing. So what we want to do is once we find out what our period is, we want to be able to find our intervals. Okay, so on normal, if we have no shifts, no anything, it's 90 degrees. But when B is not 1, okay, we're going to have a different period length, which means we're going to have to count by different things. We can't count by 90. So our intervals, okay, think of this as what I'm counting by as I go around the circle. Normally we count by 90 because that's when it's periods 360 or 2 pi. So what we got to do is we got to get those 4 different steps. So we're going to take whatever our period is after we figure it out, and we're going to divide it into by 4. Into by, yeah, you can't count. All right, so that's what B's used for. And then C, well, it's connected to X. You should remember what that is. That is going to be your horizontal shift. Okay, it's your horizontal shift. We actually, in this instance, usually call it a phase shift. Okay, and as we know, again, we've done it many, many times this year, if it's connected to X. So X minus C is going to be C units. Which way? To the right. Remember, everything's connected to X is always inverse because you're solving. And X plus C is going to be C units to the left. It's the opposite, just like it always was. And then D, well, we've had reflections, stretches, whatever, because A is going to do all that. It's just going to move it up and down, size of the waves. D is going to be our vertical shift, okay? Your midline, which that's like to be like your x-axis, your y equals D is going to be your midline. That's going to move either up or down. It's going to just shift everything. You know we're going to do examples, like starting right now. All right, so let's see. What do we want to do? Let's do a fairly simple one. We want to graph y equals 4 times the sine of theta, 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 theta. Help me, Rebecca. Or just, let me do it. All right, so 4 sine of this guy right here. 4 sine of Easter egg. Let's do that. If I call him that, then I can't missay it. All right, or mispronounce it or whatever. It's been a long day already. So, matter of fact, I'm going to change that. Sorry, guys. See, it is real, just like it's in class. I'm getting these suckers in one take. We're not doing it. 4 sine of, let's make it interesting, 3 theta. Okay? So, I want to, first of all, you know by now, I'm going to write out what A, B, C, and D are. A is 4. B is 3. Nothing in parentheses with that. So C is 0. D is 0. What that tells me right here is I have no phase shift and no midline change. So my midline is going to stay y equals 0, which is my x-axis. Matter of fact, we'll start with that. So my midline, because that's important, because that's the middle. Midline is y equals 0. Okay. What is our amplitude going to be? So we can have an idea what this is supposed to look like. So our amplitude is the absolute value of A, so it's 4. So that means from the midline to the top it's going to be 4. 4 units high. And since A is positive and the midline is 0, this also tells me that my max y value will be 4 and my min y value will be negative 4. Okay? Now we just do this step by step. First thing you got to do all the time is find your period. So my period, we don't have anything here, whether we're going to stick with degrees. Since it doesn't have a pi in it, we're going to stick with degrees. All right, so my period is going to be 360 degrees divided by B. B is 3. All right, that's right up there, right here, okay? And that's going to be 120 degrees. That means that the sine will complete one full cycle, one period, in 120 degrees instead of 360 degrees, which means I'm not going to be counting by 90. I'm going to find my interval. This is what I'm counting by. It's going to be 120 divided by 4 is 30 degrees. That means each step is going to be 30 degrees. Okay? Phase shift, we already said there's no phase shift since C is 0. Okay? So no phase shift. So we're good to go. So let's write that down that there was no phase shift. This right here means no phase shift. So we want to do at least one period to show all the intervals. You can do more. So we're just going to make, sorry I keep turning away. You probably fade off and you're like, hey. So let's just do our little. And again, guys, we're just drawing these. We're not trying to be all perfect or whatever. Just drawing them. It doesn't even matter. We're not. I know that if you're not trying to be perfect, friends, just do it. All right. right, so this is y. This is x. Remember, x is actually theta. And then y is actually the sine of the angle. So we already know that our max is 4, and our min is -4, and our midline's not changing. Midline's not changing because d was 0. All right, so we're starting at 0. So that's 0, and then we're counting by 30 degrees. So 30, 60, you dummy, 60, 90, 120, and I could go -30, -60. All right, now think, we want to do 5 points because the 5 points is going to be 4 steps. It's going to take us all the way around the circle. All right, now think about it. 4 sine on the unit circle. The sine of 0 degrees is 0. Okay, so the sine is always going to start with a y value of 0. And then if you go up the unit circle, and here's what I'm talking about, guys. Whoops. Boom. Yeah. So that was a big boom. Real life, baby. So here's what I'm talking about. Okay? The sine is 0, and it goes all the way up to a max of 1. Okay? That's as you go around the circle. It goes 0, and then it goes 1. Or look at it this side. This is maybe better. Goes 0, 1, 0, -1, back to 0. So it goes 0, max, 0, min, 0. So that's the order we want to go as long as A is positive. We're going to go 0, all right, and then we're going to go max, then we'll go back to 0, and then we're going to min, and then we're going back to 0. Okay, that's what we're doing here. So my 0 right here, sine of 0 is 0. Now, my next step is at 30 degrees, so that's a max, and then back down to 0, and then a min, and then back up. So this is kind of what it would look like. It's going to be the same shape as we were doing before, and obviously these keep going forever. This would keep going. Okay, so you might say, well, how can the sine of 30 degrees be 1? You just showed us that the sine of 30 degrees was, or that the sine of 90 degrees was 1. Well, that's true, but this is 3 times the angle. So 3 times 30 is 90. So the sine of 90 degrees is technically 1. Well, why are you at 4 then? Because it's 4 times that. See, you could plug this in and do that. You could plug in, if I could find my calculator that just dropped and almost broke my foot. Ooh, got a glimpse. So, just to show you this, think I'm not crazy here. Make sure I'm in degrees, first of all. I am. Okay, so watch this. If I put in 30 degrees into this formula right here, okay, watch what I get. 4 sine, wait a minute, of 3 times 30. It better say 4 or I'm quitting. 4, see? And we're at 4. And if I put in 60 degrees in that same thing, okay, because 60 we're saying is 0. 4 sine 3 times 60, 0. See? I'm not making stuff up. And we could go around and around and check that. All right? So we're done. We graphed it. Boom. Domain, well, it goes forever. Negative. Oh, my goodness. He is full of mistakes today, ladies and gentlemen. Negative infinity to infinity, and then range. Well, what's our low point? -4. What's our high point? 4. just like that. All right, let's take a little pause. All right, so let's do another one. Y equals cosaf. I don't know what a cosaf is. Cosine 1/2 parentheses x plus 90 degrees. Yes, I put an x instead of that other thing, so I can't mess up saying x. All right, so again, let's do this. Stop saying again, moron. All right, so in this case, a is going to equal, well, there's nothing there. It can't be 0 or the whole thing would be 0. So a is 1, b is 1/2. Careful here, c is negative 90, just like we've been doing all year long. We're solving for x, you get negative 90. And I didn't leave any room for d because it's a 0 again. All right, so midline. Don't worry, the next one I'm going to change the midline. Midline is y equals 0. That makes it nice. All right, amplitude. Absolute value of 1, which is 1. Okay, and what else do we have here? So that means our max is 1 and our min is 1. But we do have a phase shift, right? Our phase shift is going to be 90 degrees to the left because we got a negative 90. Our phase shift is a negative 90 degrees. That means this whole graph is going to shift 90 degrees to the left. The whole is going to shift 90 degrees to the left, and I'm going to show you that. Okay, so let's find our period. Okay. Okay. Sorry about that. I keep getting little ding interruptions. Make sure this is focused. Of course, I probably don't need to tell you that. You're not losing your sight. I'm just adjusting. All right. So let's do our period. So our period is going to be 360 divided by b. b is 1/2. No, that answer is not 180. It's actually 720 degrees. So that's our period. And then our interval, remember, interval is what we're counting by. So it's going to be 720 divided by 4, because we're cutting into the 4 quadrants, so to speak. And that's going to be 180 degrees. So I'm actually counting by 180 degrees. All right? So let's draw this up. Now, one of the biggest mistakes students make is they don't put their phase shift first, which is it's really, really beneficial. Because otherwise you're going to mess up. Because your phase shift shifts your starting value, so to speak. All right, we can do our min and max. 1, negative 1. All right, this is 0. But I'm phase shifting 90 degrees left, okay? So I need to come over here and I'm going to negative 90 degrees. 0. And this would be 90. And I'm going to stop there for a second. So you remember, we're counting by 180. So our phase shift was 90 degrees. So add 180 to negative 90, we're at 90. But then when you add 180 again, see, I don't want to put 180 here because I'm not counting by 90s. I'm counting by 180. So add 180 onto that. Kind of got to do the same little spread. 270. I probably don't have enough room here. Add 180 to that, and we get 450. Now, does that give me 5 points? 1, 2, 3, 4. It actually only gives me 4. And then, so I'm going to keep going. 180 to that would be 630. And I could actually go 180 back this way, too, which would be negative, what, 270? Okay, so now if you look at the unit circle, I got it here somewhere. Cosine starts at 1, starts at the max value. The cosine of 0 is 1. Now we shifted everything left, so our starting point shifts from 0 to, remember, negative 90. So our actual first point is going to be at negative 91. Now look as we go around here, okay? We're following the same pattern. It goes from 1 to 0 to negative 1 to 0 back to 1. So we're at the max already. We have no place left to go except to 0. Now, our next step has got to be 180 degrees away. So that's here. And then our next step is another 180 degrees, another 180 degrees, and another 180 degrees. So technically what we have here is we have, this one looks like this, and it would keep going. Like I said, this one would keep going through here if we wanted to, and down, and keep going and keep going. Okay, so that's a shift. So again, this was the cosine of x, and then this was x. So our domain is still negative, and I keep doing it. How many times are you going to do that? Not a negative 8. Negative and wow. Okay. Ooh. Negative infinity to positive infinity, and in our range, negative 1 to 1. I want to do those sideways now. I don't know what's going on. All right, one more, and we're going to call it a day. I think I can get through one more. Let's do a midline shift. Y equals sine theta minus 90 minus 2. Okay, so I'm going to try to speed this up a little bit. Sorry, guys. A is 1. B is 1 because it's not there. C is 90 degrees. D is negative 2. So we have our midline has moved. Our midline is now at y equals negative 2. That means this whole thing is going to shift down 2 units. All right? Our amplitude is still the absolute value of A is 1. Now that's not going to be the highest point, but that's going to be how high the wave is, if you so to speak. Okay? So, but what I do know is that since my amplitude is 1, that if I'm shifting down 2 units, my max is now going to be from the starting point of negative 2 plus the 1 amplitude is going to be at negative 1, and my min value is going to be at negative 2 minus 1. So that's going to give me my max and min points because it's 1 unit above the midline and 1 unit below the midline. And then my phase shift is 90 degrees positive, so it's 90 degrees to the right, which is nice, and hopefully this works out here. My period is going to be 360 divided by b, which is 1, 360. My intervals, what I'm counting by, 360 divided by 4 is 90. All right, so I got everything I need. All right, everything I need. So we're counting by 90, and our phase shift is 90, which makes it nice. That wasn't a very straight line. Oh well, deal with it. And all right, so let's see. We know our, let's see. So here's the deal. This was our old midline. We got our new midline is y equals negative 2. So that's coming down here. So this is going to be our new x-axis, if you will. That's y equals negative 2. So as we're counting, this would be 0, negative 90, 90. Remember, we're counting by 90s. That's our interval. till I mess up here and count wrong. That would not be good. 360, 450. What would we be at? 540 next? All right, so sine, all right. Sine, remember, starts at the max. What's our max? Now, our max is going to be at -1, actually. So it's going to be right here. And this is going to be our min. It's just going to be at 1 because we shifted down. So this is an idiot. I am. -3. I'm screwing this one up. Wow. Good thing you can stop, pause, rewind, go. So, again, our amplitude is 1. So we're 1 above and 1 below the midline. Makes sense. We shifted over 90 to the right. So remember, sine goes max, 0, min, 0, max. So shift over to the 90. Okay, so we're going to, I just wrote down the cosine. Good thing I got white out. I was waiting for you to catch that, but there's no one here to catch that except me. And I'm not re-recording this whole thing because we're like 24 minutes in. Sine starts at 0, dummy. 0, max, 0. See what we're doing? We're going around the unit circle, in case you forgot. 0, 1, 0, -1. So 0, max, 0, min, back to 0. Okay? So this time we're starting on 90 though, because we shifted. So we're going to go, so 90 at the midline is at 0, right? Then we go to our max value, then back to 0, then to our min, then back to 0. So this would be the 1 period. And then we could keep going if we wanted to. See, we could keep going. This would come down to here, and so forth. Okay? So in this case, our domain, -infinity, yay, you didn't do it wrong. Range, -3 to -1. All right, what I didn't list, and I'm going to go back, because that's nice that I can do that. Sorry, I'll go back to that in a minute and get you all busy going back and forth. So for cosine, we didn't write down. We start at 0, 0 degrees. If you look, oh, it's in my hand. I couldn't find it. 0 is a max, so we go max, 0, min, 0, max. All right, and that's what we did here. We did max, which was right here, our starting point, because we shifted. Then we went to 0. Then we went to min. Then back to 0, and then back to max. See, that's the complete cycle there. Okay, complete period. All right, I'm not listing your practice on here because I haven't decided on it yet. It will be posted on eCampus. This was a long one, folks. We're at almost a half an hour. So it was a lot. I get it. If you need help, again, I've given you many options. You can WebEx, we can talk, we can text, whatever you need. It was a lot. I get it. We'll work together on this. Okay. See you next time.